Okay, this the main website for Neo4j, neo4j.com. So, what is Neo4j? You maybe have Prolog before. Prolog, you can say that we use logic to store data or to represent knowledge. So Neo4j is similar to that, but in Neo4j we use, instead of logic, we use semantic networks. Instead of Prolog, we use graph. We store data in a graph form. So some of the companies that have used Neo4j is Google, Facebook, Microsoft, eBay, and such. So what is Neo4j? We know that we can use graph strategies to represent knowledge. So Neo4j is a platform for us to create a graph database. So why use graph? What is graph even? So graph is consisting of node and a relationship, two components, nodes and relationship. Nodes at the right side is the circle one, the one that is colorful. Customer is a node. Order, category, product, supplier. These all 5 circles represent, and the arrow is the relationship between one node and another node. So as you can see at the right side, the customer node have a relationship to order. The relationship is purchase. So these are example of graph. So why we use graph? Because graph flexible. We can update, we can add, and we can delete data in the graph database easily without compromising to other existing data. Another thing, graph is considered to be consistent in its performance. So even though we might add additional data on, the performance is still quite constant. So Neo4j use Cypher as a query language. Cypher is query language that we use in Neo4j to query things, to add, to write to the database, to read the database, and to manipulate data in the database. We use Cypher. Cypher query language. Okay. Okay, now we can go straight into the Neo4j graph data. So I will demonstrate the Neo4j graph database. So if you guys are at home, you can always try along with me. First, you guys can search Neo4j sandbox. This is a Neo4j application, a free application for us to try and play along with Neo4j graph database. Guys, if you guys have any problem, you can ask me. So when you guys come to the Neo4j sandbox, you can click launch the free sandbox. To use Neo4j Sandbox, you need you guys can always use your existing Google account or link. I will log in with my Google account. Guys, do you have any problems while waiting the page to load?
No, sir.
Okay, thanks. Okay, then the Neo4j Sandbox will select a project. So back to we will we will wait initialize the configuration. Okay, after it finish configure, then you can click open with browser. And your Neo4j Sandbox will direct you to Neo4j Browser. Neo4j Browser is the use that we to create a graph, read graph, and manipulate graph in our graph database. Hmm. There is problem with my to open this Neo4j browser at home. Okay, wait. Okay, is it lagging? The voice, is it lagging, or the audio is okay? Maybe there is a problem with internet connection. Okay, guys, can you hear me clear?
Yes, sir.
Yes, sir.
Okay, thank you. So I will try continue. Is there any of you trying Neo4j sandbox at home? May I know? Guys, is it okay now? Can you see my screen?
Yes, sir.
Okay.
Yes, sir. Can see now.
Okay, I think now is better connection. So I'm trying to access Neo4j browser by clicking the open button just now. So when I click here, open with browser, so Neo4j Sandbox will direct us to this page, this user interface, Neo4j Browser. So as you can see up here, this is a pane for us to insert queries, insert cipher queries. As I mentioned before, we use cipher query language to query, to read, to create, to manipulate data in the database. We use cipher. So the example of cipher is create. These are the example of cipher queries: create, match, merge, return. These are some of the examples. So we will use and we will learn these cipher queries to create to read and to manipulate the data in the database. The first thing we want to learn now is how to create a node. As I have mentioned before, a graph consists of two components, a node and a relationship. So first, we want to create a node. So to create a node, these are the syntax. There are create function, create command, and then there is a information that we input inside the round bracket. The round bracket represent the node that you want to create. So in this round bracket, there are first variable. Variable can be anything, any letters. For example, I use X. Then the label of the node. Okay, a node consists of label and the attributes or properties. So we want to insert the information about the data about the node. So we can, if there is any label, we can insert the label for the node. For example, node student. So inside the curly bracket is the properties or the attributes. These attributes is stored as key and values form. For example, the name of the student is for example, I will pick one of you guys. Ravin. As you can see here, Ravin is typed or is written inside a quote because it is stored as string. So as I have finished insert the information about the node, about the data, I can click here to run. Click the play icon to run the query. So this will create a node. As you can see here, the below the query pane is the result pane, where we can see the things that we have done to the database. For example, here it said we have added one label, created one node, and set one property. So the operation is successful. So next, we want to see the node that we have created, the node that is inside our database right now. So these are the cipher queries that you want to input to Neo4j browser: match and return. What match command do? The match does is the system will find the node that matching with the information that we have input inside the round brackets. So we want to see if the previously created node is exists in our database. So we can use any variable. For example, right now I use Q. The label that we have created just now is student. The name is Ravin. So we return the matching node. This is the variable. So we use Q just now. Right now we insert Q. I run these queries, and it will return the existing node in our database. So in our graph database right now, we only have one Ravin node. So it return only one node. Next, we want to try create more nodes. Okay. So right now I use similar cipher as I have as I have just used just now. I use create and I use return. So after we create, it will immediately return the node that we have created. Okay, so for example, I will use variable n. The label is student. Name is Lisa. Okay, in the curly braces, we can insert as many properties as we want. For example, in addition to the name property, the name attributes, I want to insert the age attributes. Okay, no, the gender attributes. For example, Iza is a female. We return n. So after we run this query, the Neo4j browser will immediately return the query, the node that you have just created. Okay. So here it shows Iza node. Okay, as we hover our mouse, our cursor around on the node, or as we click the node, we can see below here the properties, the attributes. Here we have the gender of this node is female. The name of this node is Iza. The above one, we can see the label of the node, student, in orange color. Okay. Next, I want to see all the nodes that we have created. Just now we have created only 2 nodes, so I want to see both of them. So similarly, we use match to find the existing nodes in our graph database, and then we use return to display the nodes in the result pane below. So instead of specifying the nodes, the properties, the label of the nodes, we can just use a general variable, so that it will return all the nodes that is in our database. So any node, whether it has a different label, different properties, it will return as we generalize the nodes, the information. So these are the nodes that we have created, the 2 nodes, Iza and Ravin. So we have learned how to create nodes. Then we can create as many nodes as we want that will represent the data in our database. The thing that I want to show you is the merge command. This cipher is similar to create command, but instead of creating a new node, a new one to the database, we will first find the existing node. If the node is already exists, then the merge function will create a new one. So different from the create function, merge will not create a new node if the same node is already exists. Okay, I will demonstrate. For example, if I use create here instead of merge, okay, if I insert the same information as the node that is in our database, for example, Ravi node, note that the Ravi node is already exists in our database. If we run this command, Neo4j will create another Ravi node. Okay, we return all the nodes. So here we have two Ravi nodes. Both are both have same information about the node, except the ID is different. So we want to avoid creating two similar nodes or two exact nodes. So what we want to do instead is to use merge function. So as I have said before, the merge function will first find if the node is already exists. If the node is exists, the merge will not create a new one. But if the node is not exist in our database, the system will create a new one. For example, if I insert same information as before, Ravin. Just now we have two Ravin nodes. If you use merge, it will stay two Ravin nodes as before. It will not create another node, another Ravin node. So we won't have three Ravin nodes. That is the use of merge function. So after we have learned about how to create a node, then we want to learn about how to create a relationship so that we can have a proper graph. Okay. These are the functions. First, similar to previous, we use match to find the nodes that already exist. Then we want to create a relationship between that nodes. So first, for example, we have Ravin, two Ravin nodes and one Iza nodes. For example, for the first node, I use X. The label is student. The properties, the name is Iza. The next node is Ravin. So in create a function to create a relationship, this is the syntax. Notice that we have two nodes, two round brackets. The first one is for variable 1, x, and the second one is for the node 2, for the second variable, y. So we have node have a relationship from this, we can use R, has a relationship to, as you can notice here, we have an arrow toward y. So the relationship will be from x to y. So we can put that Iza has a relationship of example. Okay, so here we want to create a relationship of classmate from X to Y, from Izzah to Ravin. Okay, and at the end we use return and star. This star represent all the variables that we have mentioned, so it will return all variables. Or else we can use return X, R, and Y. So I run this command. So as there is 2 Ravin, so Izzah has relationship of classmate towards 2 of the nodes. As you can see here, Izzah node has 2 classmate relationship, 2 Ravin. Okay. Okay, so after this, after we have created a proper graph of nodes and relationships, we want to know how to remove the nodes, how to remove the graph. So next, we will learn how to delete the node. This is what we do. This is what we write to delete the node. So for example, we have match. The node have already exist in our database. We want to find the nodes. We use match. We want to delete all the nodes. We can generalize the variable. To delete, we use delete X, delete function. So we run this command so that we can delete all the graph, all the nodes in our graph database. Okay, here we come to error. The system will state what is the error. The problem is we cannot delete this node because there are relationship between the nodes. So to delete node, we must delete a relationship that is connected to the nodes. So what we can do instead is we can detach the nodes from the relationship, and then we can delete the nodes and automatically delete the relationship. So here we include detach delete X. I run this command and the system have deleted 3 nodes, deleted 2 relationships. So if we return all the nodes that is in our database, match X, return X, the system will return 0, no records. Okay. So next I will show you some of the facts, some of the information in prolog form, and I will convert that prolog information into a graph form. Okay, so far okay?
Okay, sir.
All right, thanks.
I understand, sir.
Okay. Okay, so here we have prolog facts. Jack is male, Oliver is male, and so on. And we have another set of facts. Jack is parent of Jess. Jack is parent of Lily, and so on. We want to convert this into a graph form. So I have done some cipher queries similar to what we have learned before. We use create queries. So I will insert this cipher into Neo4j Browser. So as you can see here, I create 11 nodes with these properties: Jack, name, gender. Jack is male, Oliver is male. So here I put the gender in as it attributes. So I want to return these nodes that I want to create. So I run this. So it will create these nodes. Okay, for the nodes in the result pane, we can change the visualization of the nodes. Okay, the display of the nodes. So here, as I click the tutor label, the blue one, I can change the color. Okay, so graph form of data is easier for us to visualize. Okay, here we can play around, we can move around the data, the node. Okay, and then I can change the size of the node, or else I can change the caption on top of the node, the attributes that is shown on the node. For example, right now the system show the name of the nodes, so I want the system to show the gender of the node. So here we see the male and female of the nodes. Okay, so after I created the nodes and its attributes, I want to change this set of prolog data, the parent of just now. Jack is parent of Jess. I want to convert that information into a relationship. So similar to just now, I use the match cipher and create cipher to create a relationship between these nodes. So here, as you can see now, I use match for all the 11 nodes, and I use this create relationship cipher. So N1 is a parent of N9. N1 is Jack, N9 is Jess. So Jack is parent of Jess. We want to return this. Excuse me. This data that this relationship that we just created. I click run, and these are the graph of the data. Okay. So as you can see here, Ali is parent of Fatima. Ali is also parent of Simon. Okay, and so on. So here we can also pin the node so that it will not move around. But if you don't want to pin that node, we can just move around all the nodes. Okay. As you can see, it is more interactive for the graph database. Okay, for the relationship, I can also change the color, the width, the caption if there is any caption. So for example, parent of, I will use blue arrow, and I will thicken the arrow. Okay. So here is the representation, the graph representation of the prolog logic or prolog facts that we have seen just now. Okay. Okay, I think so far this is for today. How to create a graph, how to create nodes and relationship, and I also have shown to you how to convert from prolog facts to a graph form. how we store these facts, this information, this data in graph form. Okay, I think that's all for today. Then thank you.
Thank you, sir.
Wait, I will take attendance first. Okay, guys, if you have any problem or any, if you guys are interested in graph database, graph representation, you can always watch YouTube videos or tutorials. This is just introduction to graph database or Neo4j graph database. Okay. Okay, I think we can stop here. Thank you. Thank you to all. Assalamualaikum warahmatullahi wabarakatuh and goodbye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Waalaikumsalam. Thank you, sir.